Hello, everyone, and welcome to this episode of What in the World is Dyscalculia? I'm your host, Dr. Honora Wall, and this podcast is produced and sponsored by EduCalc Learning. You can find out more at educalclearning.com, and be sure you visit www.thedtri.org also to get more information about dyscalculia. And I want to talk about a research article today. This was a research study conducted by Shalev and Grosseur titled Developmental Dyscalculia. I'll be putting this on the dtri.org website so you can read the full PDF, read the full study for yourself if you are interested in research the way I am. If you're not, it might be a little dry, so let me recap it for you. Basically, the study was looking at different research that's published about people with dyscalculia and what are some of the signs and symptoms and what do we see across the lifespan. So if you've been listening to our podcast for a while, this information will not surprise you, but if you're brand new, it might be something that you don't know or you haven't heard before. The first thing they talked about in the article is the fact that, and I've read this in many different places, if you've read anything about neuroscience or just math in general, you know this to be true already. Reading is something we have to teach. We are not born knowing how to read. Language and alphabets, those are things we create, and then we teach each other how to use them. So this is important because there's such a tendency for people to say, oh, it's the number dyslexia. No, my friend, it is not. Please take that out of your vocabulary. There's also a big movement for a lot of programs that are based in dyslexia research or reading-based programs. Now, on the one hand, I think any program that is working for you, your children, your students, keep using it, because if it works, don't mess with it. And if it is not working, then there are probably some reasons why. You might be fixing the reading-based issues. You might have a person who's comorbid, more than one specific learning disorder. Or it might just be that you're helping to clear things up and that's what's making the improvement. However, if you look at fMRIs, you look at the types of symptoms and you start to dig into the causes, you're going to see that dyscalculia is completely different from dyslexia. Math is an intuitive, natural process. You wouldn't know it if you're in a K-12 system, especially here in America. You would be very surprised. However, all people all over the world from the dawn of time have counted, have organized, have classified, have separated things, have dealt with quantity. Even before we were using bartering systems or developing economies, we were still counting. And even if you go to very remote tribes, if you can still find some in the world today, we can still find people who count. A lot of times you'll find groups of tribal or groups of people that we've discovered in the Amazon jungles, things like this, where there's not a lot of interaction with what we like to call the developed world, where we find people who are counting to 1, 2, 3, many, because above 4 it's rather collective and we didn't really need to differentiate. But we're still counting, we're still sorting, and we're still using the idea of more and less and the idea of grouping things. That is a natural part of the human condition. Why is this important? Well, when we're looking at a learning difference, when we're looking at dyslexia versus dyscalculia, dyscalculia has different causes. There's some kind of wiring or coding, or maybe it's a blend. The research is still unclear because we need to do more studies, but there's something different that's interrupting this very natural human process. And I think that makes a real big difference in the types of interventions and accommodations that we use. And our approach can be a little more refined when we're talking about dyscalculia, which is the math-related learning disability. It is not number dyslexia, although I know that is a popular term, mostly because so many people have heard of dyslexia. So if you're speaking with someone who's never heard of dyscalculia, it can give a frame of reference. And I totally get that, but they are very different issues. Okay, so that was the first thing that really caught my eye in this research article. And another thing that this particular article focused on was the early elementary experience and really going up to 5th and 6th grade. This is where a lot of research has been done for dyscalculia. We need so much more for older students, especially high school and adults. We just really have a lack there, and hopefully that will change soon. But what we do know is that when you look at the elementary experience, up to about 5th or 6th grade, you're seeing students who are using ineffective or insufficient strategies for their counting. And so adding, subtracting, multiplying, it's taking them forever. They're still counting on their fingers. And that's embarrassing also. The older a student gets, the more they try to hide those strategies. And that's one of the reasons, the many reasons why I highly recommend you let students use a 1 to 100s chart, a multiplication list. Once you get into 5th grade, start introducing that calculator on occasion by your topic, and then in middle and high school, we have moved on to other things. Use the calculator. Use a list of all the common square roots and cubed roots so people can refer to these outside sources. That way they can keep up with the rest of your lesson. And that is what this research article really talked about. The problem with using insufficient strategies, not being able to rely on memorization for basic facts, that takes up so much time. It also takes up a ton of mental energy. Your brain is exhausted. So trying to keep up with the lesson, trying to learn the new vocabulary, trying to focus on the difference between perimeter and area, and when you use those formulas, understanding what a formula is and substituting digits for letters so you can work with a formula. Don't even get me started on working backwards if you know the area and you have to move backwards to the given side. All of those other things that we want students to focus on, they're having a hard time holding that in short-term memory and moving it into long-term memory and keeping up with what's going on because they're still trying to figure out the adding and getting to the right answer. So we see a lot of errors as students are getting older. We know they have some kind of issue. We may or may not have a diagnosis, but we know that they don't have the memory that gives them a boost. That's an important thing to think about. For students who do not have dyscalculia, who are memorizing like the Dickens, and they've got tons of basic facts at their disposal, their brain is using that internal mental number line and those memorized facts as an internal tool. But they're not doing something super special or something super different. And here's my analogy for that. If a person needs to wear eyeglasses, this is an external tool that helps them to be able to see clearly. When you can see clearly, you're more likely to read completely and without errors. When you read fluently without errors, you're more likely to have a better reading comprehension. So do you see where I'm going with this? A person who does not wear eyeglasses is still doing the same reading, the same fluency work, the same comprehension, but they have an internal system that's doing a lot of work for them. And if a person is nearsighted, farsighted, a little older like me, if I don't bring my readers out with me, I'm going to have a hard time. We need an external tool to help that process. Once we have it, then we can read fluently, we can read with great comprehension. So the accommodation can be the barrier or the thing that removes the barrier. Very important to keep that in mind. So for students with dyscalculia, we're going to see those insufficient strategies that are not helping them out, but they should be doing grade level work. These are students who have average to above average IQs. They're not behavior problems. They need to be in a gen ed classroom, and they're perfectly capable of keeping up if they have the right accommodations. And since those counting strategies and the memorization tools are not as strong, we need to give them some help in that area. When we don't, we're going to see a lot of little errors. We're going to see that they're so close to having the right answer, but it's a little off. And we're going to see that the work of computation and performing those 4 basic operations is so intense that these students are exhausted mentally by the time we try to get to the vocabulary, the concepts, the higher level math problems we want them to do. So keep that in mind. Keep an eye on the classroom. Do people seem like they're dropping off? They're losing pace. They're getting frustrated easily. They're 2 questions behind because they haven't kept up with the numbers. Then you're going to see students really disengage and give up because they don't feel like they can get there from here. Part of our job in the classroom is to help students get there from here. And we can do that easily with those external tools that, again, if you've been listening to the show, you know I love to talk about them. 1 to 100th chart, number lines, multiplication list, later on a calculator, worked examples, having some notes that make sense to the student and letting them have that while they're taking their assessments. The same way you would let your students wear their eyeglasses when they take their assessments. Not really a big difference there. Okay, so to wrap up the developmental dyscalculia article by Shalev and Gross-Sewer, reading is a natural process for most people after they're taught how to do it. But they're not just born understanding any alphabet and how to read it. Math is a natural process that's happening on its own. Counting, sorting, organizing, more or less, develops without any prompting or instruction from us. We use that basis to uncover the rest of the very interesting things that we know about upper level math concepts. So therefore, since these are very different things we do that come from very different places and involve different parts of the brain, we want to address issues with different interventions, accommodations, strategies, and support. You're really going to see the worst of the dyscalculia impact in elementary school, and some things like that dyscalculia trifecta, time, money, place value, they can remain a problem even into adulthood. But you're going to find that other upper level math concepts are much easier because now we're requiring calculators. So upper level math gets to be much more accessible for students with dyscalculia. Well, there's a lot more to say about the math learning disability, and we'll keep diving into it in our podcast throughout the year. If you have questions or comments, please find me on social media. You can find EduCalc Learning or the Dyscalculia Training and Research Institute on Facebook, LinkedIn, TikTok, here on the podcast. You can visit the websites www.educalclearning.com or www.thedtri.org, and make sure you check out our books. You can get your copy of Teaching Students with Dyscalculia in English or in Spanish at your local bookstore, through Amazon, or on the website. You can get your box of the Teacher's Dyscalculia Toolbox. That's out there. There's some other books out there. I especially like AHA Games for the Brain for classroom activities. And if you just have some questions, email me and I'm happy to get some information to you and help you support your students. I'm Dr. Honora Wall. This is the What in the World is Dyscalculia podcast. Thanks for listening.